Welcome back to another explainer. If you're a focused learner looking to understand the exact mechanisms behind manufacturing excellence, well, you're in the perfect place. Today, we're diving into a really fascinating analysis of Masterbatch Quality Control. We're going to break down exactly how top-tier manufacturers guarantee their products perform flawlessly every single time. Okay, let's dive into this. Picture this very real scenario on the factory floor for a second. You have the exact same chemical formulation. You're running it on the exact same processing machine, yet one batch passes perfectly and the very next batch gets completely rejected by the customer for color variation. Why does that happen? Is it just the formulation? Absolutely not. Formulation is definitely not the only factor at play here. The real hero, that invisible shield preventing processing nightmares and those dreaded black specks in the final plastic, is rigorous quality control. To solve this mystery, we'll just follow the chronological life cycle of a production run. Here's our agenda for today's explainer. Number 1, the QC mystery. 2, raw material inspection. 3, core laboratory testing. 4, the batch release checklist. And 5, solving customer complaints. Let's get right into it. Section 1, the QC mystery. More than just pass or fail. A lot of people just assume a quality control department sits at the end of a line and simply stamps pass or reject on a finished box. But a truly professional QC system does so much more than that. A strong QC framework really relies on 4 main pillars. First, ensuring batch-to-batch consistency, so the customer gets the exact same product in January as they do in July. Second, meeting highly specific mathematical customer specifications. Third, maintaining process stability on the machines. And fourth, preventing future customer complaints before the product even leaves the loading dock. These 4 pillars are the absolute foundation of a company's reputation and customer trust. Honestly, if you fail here, the best formulation in the world is totally useless. Moving on to Section 2, raw material inspection, the first gatekeeper. The absolutely most critical testing actually has to happen before production even begins. Rigorous checks are performed on every single ingredient that enters the facility. For the base polymers, technicians check the melt flow index, moisture levels, and look for any sort of contamination. For the pigments, which, of course, give the plastic its color, they check the shade, the tint strength, how well it disperses, and they demand heat stability certificates. And for the additives, they perform appearance checks, verify batch numbers, and confirm shelf life. You simply cannot assume an incoming material is perfect just because it's brand new. And that leads us to the golden rule of the industry. Bad raw material always equals a bad final master batch, period. I literally cannot emphasize this enough. It doesn't matter if you have millions of dollars of advanced compounding machinery. It doesn't matter how incredibly skilled your operators are. If the incoming ingredients are flawed, the final product cannot be saved. You just can't engineer your way out of bad raw materials. Section 3, core laboratory testing, the processing gauntlets. So, assuming our raw materials pass that first inspection, we move to production and right into the real gauntlet. Let's start with MFI, or melt flow index. This metric tells you exactly how easily the molten plastic will flow. High MFI means an easy flow, making it super suitable for thin wall products like disposable cups. On the flip side, low MFI provides high physical strength, which is suitable for thick, durable products like industrial pipes. The crucial takeaway here is this. If your master batch MFI falls outside of the customer's specific machinery specs, it's going to cause major processing nightmares for them, which results in immediate rejections. After flow, we've got to test color. To do this, the lab uses a highly precise instrument called a spectrophotometer. This machine mathematically breaks down color using 4 specific data points. L star measures lightness and darkness, A star measures where the color sits on the red to green axis, B star measures the yellow to blue axis, and delta E calculates the total overall color difference compared to the standard. It essentially takes highly subjective color, which, let's be honest, you and I might argue over, and turns it into undeniable math. But as amazing as all that math is, final color approval requires both instrument readings and human visual inspection. We just can't forget the human element here. While machines give us objective numbers, human eyes are still absolutely essential for final shade approval, especially under different lighting environments. A machine might say the color passes, but a human eye might catch a really subtle, unnatural tone. You need both to be completely certain. Next up in the gauntlet is checking how well the color actually mixed into the plastic, which is known as the dispersion test. If the pigment didn't uniformly mix, you'll see some pretty obvious visual red flags. You're going to get black specks, unwanted streaks running through the plastic, weird concentrated color patches, or an uneven surface gloss. The lab hunts for these defects using visual blown film tests or deep microscope analysis. If any of these signs are present, the batch is compromised. Beyond the visual and flow checks, we also have some really rigorous chemical checks. To find the exact filler levels, we perform an ash content test, which literally involves burning the plastic to ash at extreme temperatures. Then there's the moisture test. This one is incredibly critical for moisture-sensitive polymers like nylon, PET, and polycarbonate. If there is even a tiny little bit of excess water in the plastic, the high heat of processing will instantly turn it into steam. That ruins the product with silver streaks, bubbles, and a massive loss of structural strength. Section 4. The Batch Release Checklist. The ultimate gatekeeper. After surviving all that testing, we reach the final hurdle before product leaves the factory doors. This checklist is a strict, sequential process that simply cannot be bypassed. Step 1. Formal color approval. Step 2. The MFI and dispersion checks must pass. Step 3. Ash and moisture validation limits must be completely met. And finally, Step 4, a physical check of the final appearance, the integrity of the packaging, and the accuracy of the labeling. Let me be totally clear here. If a single batch fails even one of these steps, it does not get dispatched. The whole system is designed to catch failures internally so the customer never even sees them. Section 5. Solving customer complaints. QC as detectives. Now, in the real world, occasionally a problem slips through, or a customer runs into an unexpected issue. Take this 4-day timeline, for example, which plays out a bit like a mini true crime detective case. Day 1, a complaint comes in. A customer reports their gray Masterbatch shade is varying. Day 2, the QC detectives start their investigation. They confirm it's the exact same formula and the exact same machine, so what happened? Day 3, they find the root cause. A new batch of raw pigment was used, and its specific tint strength was just slightly off compared to the old batch. Day 4, the permanent solution is implemented. They upgrade the incoming raw material QC to strictly test tint strength on all new pigment deliveries. Boom. The detective work solved the current problem and prevented all future ones. And this brings us to a beautiful summary of how this whole ecosystem actually works. Consistency equals R&D plus QC. There is a vital symbiotic relationship here. Research and development are the architects. They develop the brilliant formula. But quality control, they're the enforcers. They ensure that every single production run accurately matches that original formula. You simply cannot have one without the other if you want to build ultimate customer trust. I want to leave you with this absolute drop-the-mic conclusion from our source material. Quality is not made by accident. Quality is controlled at every stage. Excellence in manufacturing is highly deliberate. It requires constant vigilance from the moment a raw material arrives to the exact second the finished product is loaded onto a truck. So, having seen this rigorous life cycle of consistency, I want to leave you with a provocative question. Looking at your own work or your own business processes, how are you planning to upgrade your quality control checks tomorrow? Think about it. Thanks for joining me on this explainer, and keep learning.
Before you leave, let me tell you a true-to-life story that happens in the plastic industry more often than people realize. A customer receives an entire truckload of Masterbatch. Production starts smoothly, but within a few hours complaint begin purging in. The color doesn't match. Black specks are appearing. The MFI is too high. The dispersion is poor. Suddenly, thousands of kilograms of finished product are rejected. Production stop. The company start losing money every single minute. Now come the biggest question. Who made the mistake? Was it the raw material supplier? Was it the wrong pigment? Dye the MFI changed during processing? Was the dispersion never checked properly? Or did the QC team ignore a small delta E difference that later turned into a massive customer complaint? This is exactly why quality control is not just about testing. It is about protecting a company's reputation, customer trust, and millions of dollars. In the next episode, I will take you inside a real QC investigation. We will analyze a customer complaint step by step, check every raw material, measure MFI, inspect dispersion quality, compare delta E value, and use a real industry problem solving method to discover the actual root cause. And I will promise you, the final reason behind the failure is something that will surprise even experienced quality engineer. So, doesn't miss the next video. Subscribe now because the next lesson could save your future job, your production line, or even your biggest customer. See you in the next episode.